So we're into a brand new chapter, chapter 7, which is about a thing called radical expressions. So if you look through my board, you see a whole bunch of radical expressions. Some words to introduce you to. The radical sign is something I have on my board probably 50 times, I would guess, ballpark. What is that?
Like square root?
Yeah, it's the square root symbol. It's kind of like if a check mark married a division box and they had children that had both of their traits, that's called a radical sign. It's the traditional square root symbol. The radicand is something, the index is something. Anybody have a thought on what the radicand is or what the index is for these stories?
I guess one is the little number, and
One of them is the little number, and one of them is the big thing. Does anybody know? Like for this, the 3 is one of them, the 2x plus 3 is the other one of them. Does anybody know that? The 3 is the index. The radicand is this entire thing that's under the radical sign. Some of these problems don't have written an index. What is the index if I don't write it?
2.
It is a 2. So, because what is this symbol traditionally to you that you already said? Square root. Square always has to do with 2's. Cubing has to do with 3's, and so on and so forth. So if you don't see an index, it is a 2. Question about the words. So if you go to do the square root of a positive number, that has a different outcome than the square root of a negative number, which has a different outcome than if you do the square root of 0, because 0 is neither positive nor negative. If you go to do square root of positive versus square root of negative versus square root of 0 and count the answers. Anybody have memory of how the counts go? Positive has 2 answers, potentially. Negatives? You have what? 0. And the square root of 0 has 1 answer. The square root of 0 is 0. That's your only answer. Square root of negative, for now, continues to be impossible until we get toward the middle of this chapter and it becomes possible with the introduction of some new math to your life. I think around 7-6, maybe that's going to happen. Square root of positives have 2 real answers. Like, if I ask you to do the square roots of 9, how does that have 2 answers?
-3 positive.
-3 and +3. Why is 3 one of the square roots of 9? Because 3 times 3 is 9. Why is -3 also just as good of an answer? -3 times -3 is also +9. So square root of positives, sometimes you'll want both answers. Sometimes you'll want only the principal square root. What's the principal square root mean? Memory of that? That's the positive answer only. Anytime you see this symbol used, you only want the principal square root. So if I want both answers, I have to say with words, what are the square roots of 9? Then you give me back 3 and -3. But over here, where I'm using the radical sign as my symbol, I only want back the 3. Only the positive answer comes back out of the radical sign. So what would you have to do about this for now? It's impossible. Square root of negatives are impossible because there's no way anything times itself can turn out negative. How about this? It is -3. The square root of 9 is 3, and then the negative is just hanging around to get capped on there. How about this one? It is positive or -3, which I could write like this, or I could write like that. That's really up to me or you or whoever's writing it. Those are the same answer. Question about the ideas so far? So, and let's do a bunch of them. This
Fine.
is just 5. This is 4 over 7. This, you might want to grab calculator. Some of you might feel comfortable without calculator. I don't know. It is 0.03. The square root of 9 is going to be in the 3 family. And what happens to the length of it? It shrinks exactly how? Half as long. So if this had been 8 places long, the answer would be 4 places long. If this were 7 places long, you have a problem on your hands, so you need to use a calculator. There's no quickie way to do that anymore. Cube root of 8 is 2. Why?
That's 2 times 2 is 4 times 2 is 8.
Yeah, 2 times 2 times 2 gets me to 8. Cube roots of negatives.
-2.
It is -2. Cube roots are possible because negatives times negatives times negatives
It's negative.
can make negatives. Basically, it comes down to a disparity of 2 types of numbers could be here for your index. What do I mean by you could get 2 types of numbers that could take us on 2 different kind of scenarios?
It's all you can have negative if it's even.
Odds versus evens. Odds, you can do odds with negatives. You can't do an even index with a negative. Over here, if people wanted to get argumentative but lose, they'd say, there's no index over there. There is an index over there because I said index is 2 if I don't write it. So if you have an even index, negative number, you bail. Odd index, negative number, you just get a negative answer, no harm there. This is called a 4th root. 4th root of 81, you're trying to think, something times itself, times itself, times itself in quadruplicate. Some number, 4 of them gang up to get you to 81.
3.
It is 3. Because 3 times 3 is 9. Another 3 times 3 is 9. A couple of 9s is 81. You know, 4 3s get you to 81. Another way you could do the 4th root is to do the square root twice. Square root to 9, square root to 3. 4th root is like a double square root. 4th root of 10,000 is 10. Because 10 times 10 is 100, another 10 times 10 is another 100, a couple of hundreds make 1,000. If you have 4 zeros and it's a 4th root, it just sort of undoes each other, you're back to 10. 6th root of 64, something times itself, times itself, times itself, times itself, times itself, you know, gets you to 64.
4.
It's not
2.
4, it is 2. Because if we start doing 4s, it gets big fast. 4 times 4 times 4 again. We're already at 64, and we still have a bunch more 4s to do. 2 times 2 times 2 times 2 times 2 times 2. There we are. So 6 2s get us to 64. Did I lose anybody through that call? If you didn't like trying to do those in your head, there should be a button on your calculator. You probably have this button to do square roots. You possibly have this button to do cube roots. You should have a button that looks like this that can do any root. So chances are this one on a calculator, you could go 6, find that button, 64, and get the 2 popped at you. That should be a thing you can do. It's just a matter of finding the buttons. If you're worried about buttons, we can find the buttons. If you borrow calculators from me, we don't have those buttons anymore. The like dollar calculators, they're going to have square root button and that's it. There's maybe 3 calculators in that box that might have that button, but the majority of those will not. Question through that group. Then here's like a little bit more of a trivia question. Okay, the ability to do all this stuff up to now is probably like on a scale of 1 to 10 for this chapter, like a 9, maybe a 10. The ability to do what we're doing from here for a little while is going to matter today. So it'll matter on like this much of a page of a quiz and that much of a page of a test. This is just like a little bit of a trivia question, and they'll work around this the rest of the chapter. But we just decided a minute ago, if we had an even index, we wanted to make sure we got a what kind of answer? positive. So anytime this symbol is used with an even index, we only want the principal answer, meaning we have to make sure it's positive. If you have an odd index, was that problematic, or it just like did what it needed to do? It just did what it needed to do. When we had an odd index, I go positive problem, you go positive answer. If I go negative problem, you go negative answer. You just keep it the way it was, no one cares. Okay? But when we're going with even indexed stuff, it has to come out a positive answer. So these are going to have slightly different results. What would you expect to happen if you had a number, you took it to a power, and then you immediately did the same root? It would be that number back. So both of these have to do with just taking the number in there and copying it. But one of these two has an extra math thing we're going to need to do to guarantee positivity. What's a math thing from way back that guaranteed positivity to us? Absolute values. The even ones are going to just need absolute values to guarantee positivity. Half the homework tonight, the back half, is going to do this. Tomorrow they'll bypass this because they'll just say to you in the instructions, assume everything is positive. So if you assume everything is positive, you don't need the bars anymore, we're just good. But for today, they want to just have us make sure we understand when the radical sign is used, they only want the principal value, the bars are going to get you positivity. So this is x, this is x. One of these has bars, one of these does not. Top one has? Okay. One of these two is negative 2. One of these two is positive 2. They both have to do with 2. Okay, if we're going powers and roots that are match, you kind of just are running in a circle and end back where you started. But one of these we'd want to keep the negative. The other one we'd have to use the idea of absolute values and positivity to get back positive.
The 3 you keep the negative?
This one we keep the negative.
That one's absolute.
That one has to get absolute valued so it becomes positive. Anything even has to be positive. If it's a number, just make it positive. But if it's a variable, just throw the bars on it. So this is going to be x plus 3 for sure. This is 2x plus 3 for sure. This is x plus 8 for sure. This is 3x minus 4 for sure. This whole column, we're just copying what we came in with. 10th power, 10th root, they just nullify each other. The only real question is bars or no. So, bars?
No.
No.
Bars?
Bars?
No.
No. And to recap, if people were missing it, bars whenever the
Thing is even.
index is an even number. Question about those? Let me stroll leftward for one more column. For a little while we did numbers, for a little while we did variables, now we put it all together. So cube root of 8 we did 2. This xy stuff would make us put x. Care about bars or do not? Do not, because odd index. Square root of 4. 2. This. X. Care about bars or no? Yes, because the index was even, it was a 2. We don't need bars around this because this is already positive. So just do that. That works for multiply, that doesn't work for add. So back over there were some adding problems. The whole adding problem had to be surrounded with bars. Multiply problems, you don't have to worry about that. I could show you why if you cared, but I don't know if people will care. But adding is different than multiplying for the usage of bars. This square root of x squared, it's just an x. What would the square root of y to the 4th be, do you suppose? Y to the 2nd. Who needs bars? Not the whole thing. Why just the x? Why doesn't the y squared need bars?
Because if squared is going to be positive.
Anything that goes to an even power is going to be positive naturally. The only thing that's a little bit of a mystery is this x. So the x needs bars, the y squared really doesn't. We've got positivity there. What do you think the 3rd root of x to the 6th would be?
Probably x2.
It is x2. How do you think the simplest way is to work that math?
Divide them.
Divide them. If you have powers involved, divide the index into the exponent. If you divide the index into the exponent, we're good.
Y to the third.
Y to the third. Divide the index into the exponent. Are we thinking about bars? No. Why are we not even thinking about bars this time?
Because it's to the third.
Because it was an odd. If there's an odd index, forget the bars. If it's an even index, size it up. So this, x is to the second, y is to the third. Are we even thinking about bars?
Yes.
Yes, because this is even. Does this need any bars?
Y to the third.
Yes or no on the x's? No. Why? Even power. Y to the third?
Yes.
Yes, we do need to do something there with bars. Does anybody remember from chapter 2 what we did with y to the third kind of stuff? We want to leave as little inside of bars as we can get away with. So if we did this, there's more in the bars than is absolutely necessary. There's a less stuff in bars way to take that.
2y and then just 1y divided.
Yeah, we bring out as much evenness as we can, which is 2. And you only ever have to leave in 1. Like from the Wayback Machine, if I did the absolute value at x to the 31,
You take out x to the third.
we bring out 30 of them,
And keep the one.
and you only ever leave 1 in. You should only ever have to leave 1 of them in. Question about that. So the 81 part,
9.
9. Also,
X.
x. Are bars in consideration?
Yep.
Yes, because the index 2 is even. Who needs the bars? Just the x. 49? 7.
Y.
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 Bars around the y.
X squared.
5x squared.
You're good?
We're good. Did we have to think about the bars?
Yes.
Yes, because this was a 2. But we didn't actually need them because 5 is positive and any even power is positive. And the goal of the bars is to make things what they already are. So we're good. This, x plus 3. Bars where?
Around
Everybody. If it's adding or subtracting, we need bars around everybody. And if you want to know why the rules are different, I'll launch into an explanation of that. If you don't care, I'll spare you. This, what do you have to do before you can really, you have to factor. Factoring is occasionally still in play. How does this factor? X plus 4, x plus 4. In other words, x plus 4 squared. So that's out, the new thing's in. Answer is x plus 4 bars around whole thing. Question about anything to do with radicals? Again, this bars thing, it's important today, but on a scale of 1 to 10, it's like a 2. It's not going to appear every day throughout the chapter because, like I said, the directions in most of the future days will say, assume that these are all positive numbers. And that is a little bypass around that. Today, homework, we're 295, we're skipping 3s, we're working to 52, which sounds like a ton. It's probably like, what is that, about 35 problems? On the board, we probably just did 35 problems. Like, so it's about not much bigger than probably what we did. But 295, fire away. It's a hoops night tonight, so 20 minutes, make use of that. You won't regret it when you get home at the end of a very long hoops night.
I heard about the numbers.
Yep.